So from Hungary, we're now moving on to Norway and housed Herefords in relation to heat detection methods by visual observation and heat time, and then as a timing of ovulation. Thank you very much. The floor is yours.
Thank you. Particularly snappy title, isn't it? Many thanks for the organising committee, not just for asking me to talk today, but also for going to the effort of putting the whole thing on. It must have been a mammoth effort. So, a little bit of a background to the talk. Generally, I would say probably throughout the world, AI in beef cattle has been underused. Of course, because of the nature of its extensive agricultural form that we see in most parts of the world. In Norway, there's been a big push to try and increase this to hopefully gain some of the productivity improvements that we've seen in the dairy industry. But unfortunately, farmers particularly find oestrus detection difficult. Many of the beef farmers in Norway have converted from dairy to beef farming, so they're familiar with oestrus detection, but have commented they find it particularly difficult in beef cattle. There's also, as we've heard about today, a considerable number of people in Europe that don't really like the idea of routine use of hormones. On top of this, we've seen that there's a changing pattern in signs of oestrus in dairy cows. So we're seeing less standing to be mounted, partly probably due to genetics and metabolic stress, partly probably because of endemic disease. And we've also had reports of interbreed differences in oestrus behaviour. But despite all of this, we haven't really spent very much time collectively looking at beef cows, and the majority of work on AIs in beef cows has been solely focused on timed AI, which has been remarkably successful in many parts of the world. So the study aim was a very simple aim. We simply wanted to find out how long does it take for a cow to ovulate from the time that we identify oestrus. Quite straightforward, but very, very important and critical if we're going to get successful rates of pregnancy. A study was performed in Sweden with our colleagues there. We used their study herd of the Swedish Agricultural University, 40 pedigree Hereford cows, and we were there for 5 weeks. They were all loose housed on deep bedded straw. We used heat time activity measures. We used the standard manufacturer settings. Again, there's been some discussion there if we should have used slightly lower settings, but the study showed that the manufacturer's advised settings for dairy cows were spot on. And we also visually observed the animals 3 times daily for 20 minutes at 6 o'clock, 2 o'clock and 10 o'clock at night. And we assigned behavioural scores, and when these scores for each period of observation summated up to more than 100, we defined them as being in oestrus. After we'd defined them as being in oestrus, either by and the two studies went parallel to one another. So if they were detected as being in oestrus either visually or through the activity measures, we set them into a program whereby we performed transrectal ultrasonography every 8 hours, and we continued that until we'd identified ovulation, obviously not actually the moment of ovulation, but the disappearance of the ovulatory follicle. Concurrently with this, or throughout the whole study, we took thrice weekly blood samples, which we analysed for progesterone, and we used this to define the gold standard and to ensure that we did actually have oestrus. So we were looking at we had low levels of progesterone at the point of ovulation, which were then followed with a subsequent rise in levels of progesterone. In total, we had to exclude 2 animals from the study. As you can see, that gave us 14 heifers and 24 multiparous animals. There were no primiparous animals in the herd at the time we did the study, so that's why that class of animals missing. In total, we had 50 heat time reported oestrus events, and we had 40 oestrus events that we observed ourselves, which I must say we were slightly disappointed with. We thought we'd done just about as well as the machine, but the evidence showed differently. We performed survival analysis to try and estimate the time to ovulation. And we got some results that we found quite interesting. As we can see from the numbers there, we're looking at in total around a mean for heifers of 21 hours from the point at which we identified oestrus to ovulation in the visual method, and in the automatic system it was 23 hours. So that's actually a little bit less than a little bit of a shorter interval than has previously been determined. Of particular interest to ourselves was the fact that 25% of the animals had already ovulated after visual detection after just 13 hours. So this would mean the kind of fairly standard, you see an animal in heat and you wait 12 hours and inseminate, would mean that we've missed at least 25% of the animals if we practice that. If we also bear in mind that we were doing 3 times daily visual observation, the majority of farms we struggle to get to do twice daily observation. So that means that in all likelihood actually we'll be having an even shorter interval between detected oestrus and ovulation, which has some fairly significant practical implications. The Heatime activity measure, that's a rolling measuring system that takes 2-hour blocks of time and obviously is continual. So the moment that the alarm says peep, in effect, that's when oestrus has been detected. And there obviously we're seeing a slightly longer time period before insemination, but still shorter than has been reported in both beef and dairy cows up to this point. We did see some difference in heifers and cows, but not a significant difference when we looked at it statistically. So as you can see, the heifers actually took a little bit longer in these studies to ovulate after oestrus was detected. But as I say, statistically, these differences weren't significant. So to sum everything up, what does this? What do we take home, or what's the message that we try and take back to the farmers about this? We see that certainly compared to Holstein cows, previous studies that have been reported, the animals in this study ovulated around 6 hours sooner. And our implication or inference out of that, although we don't have any data to back it up, we haven't tried this, would be to say that we need to perhaps consider inseminating cows a little bit sooner. The situation in Norway is inseminations largely performed by veterinary surgeons or technicians. And in order to place an order for that, you have to ring in before 10 o'clock in the morning, and then you get the vet the same day. If not, you have to wait a day. So that really means in the Norwegian system that we need to train more farmers to do this themselves, or we need to consider using oestrus synchronization regimes if we're going to achieve successful results with artificial insemination. We're quite aware of the limitations of this study. It's one study, it's a relatively small study, but we put a lot of effort into it. It was a very detailed study. It does have some fairly significant practical implications, and obviously before we go out and start trying to change the world and change the recommendations of artificial insemination timing in suckler cows generally, or in pedigree Hereford cows, we're going to obviously would like to try out some larger multi-site studies. And obviously I'd just like to thank the people that made this study possible, largely a collaboration of industry groups and producer-based groups in Norway, and also with our colleagues in Sweden for facilitating the research at their research farm. Thank you.
Thank you very much. Questions from the floor?
Micha Schouts, UCD, Dublin. Thank you very much for this nice presentation. Maybe I missed it, so I apologize if I did. I have 2 questions for you. The first one is, how many days in milk these cows were? And if that was a suckler herd, if the cows were still present with the heifers, with the cows.
Okay, the first question I didn't quite catch. The second, the cows had all calved. I think the nearest one to, or the most recent calving from the start of the study was 22 days, and then they were out. All of the animals except the one were in cyclicity, but the calves were present.
Okay, thank you very much.
Any other questions?
It's in Scotland. Thank you for a good presentation, Adam. I may have misunderstood, but in one of your early slides, you had a number of anestrus animals. It looked like 8.
Yes.
That seems like quite a high proportion out of 40 beef cows. Do you have any thoughts on why you got that rate, or have I just misunderstood the numbers?
Yeah, the animals there, the heifers, and they were largely speaking heifers that were anestrus. So they hadn't actually, or we didn't detect any estrus. So they hadn't actually come into cyclicity, or had come into cyclicity and stopped.
And yeah, sorry, is that just an age-related thing then, or?
Well, they were 13 to 16 months of age, so they were the correct age, they were the correct weight, but obviously something wasn't quite working there. But we didn't investigate exactly what.
I have a question related to that, because you had anestrus and silent estrus, both of them, those, and because you were doing ultrasound, how many of those anestrus were anovulatory anestrus, or were they just being, like, you obviously defined them as in silent, as in something did happen, and the rest, were they cycling at all? Did they have follicles that were turning over, or was there absolutely nothing happening on those ovaries?
The only animals that, because we quite intensively, rectally the animals every 8 hours, we consider to be quite intensive. So we only examined animals after they'd had a defined estrus event. So I couldn't comment on the follicular turnover of the animals.
So they had to be spotted in heat first,
spotted in heat.
And then you started. There wasn't a pre-scan before they were enrolled in, like, now you can come in heat, and then we start following you intensely.
Yeah. No, we didn't do that.
Very good, very good. Any more questions from the audience? No? We're slightly ahead of schedule. I don't know, that's probably quite unique, but I like to keep time, so I'm going to move on to the last speaker, if you don't mind. So thank you very much.